In this question, we are given a canonical transformation going from one set of coordinates of P and Q to another set of coordinates P and Q is formed by the Hamiltonian. The old Hamiltonian is given and the generating function is given. Now, which of the following graphs is right for the dependence of the new coordinate on T? So, the new coordinate Q and T, which of the graphs are right? So, let's try to go about this problem. So, we'll start in a new page. So, the given Hamiltonian is equal to P square by 2m plus half m omega square q square. Now the generating function is given. The generating function given in the question is nothing but half m omega q square cot q. So this is the new coordinate q. So the new old momenta and the generating function are related this way. So we have and the new momenta and the generating function are related this way. So the new momenta P and the generating function are related this way. Now from this equation, we can rearrange for Q. We can rearrange for Q in terms of P, and what we get is, so we rearrange Q in terms of P. So we rearrange this equation in terms of, let me go to the next page. So if I rearrange this equation, I get Q in terms of the new momenta as so I've just rearranged this equation to get Q. Now what I'm going to do is I'm going to substitute this value of Q in our equation that we got for P. Okay, this equation. So let me call this equation number 1. Okay, so substitute Q in 1. So what I get is P is equal to m omega so now what we have is P is equal to 2P now let me find out the new Hamiltonian, which is K, which is given by H plus the time derivative of the generating function. So this is our new Hamiltonian. So our new Hamiltonian, when we solve this, we find that it is nothing but K is equal to omega small p. So now we have P dot P dot, the Hamilton's equation says that P dot is nothing but minus dk by dq. So when we take the derivative, we get that this k is not a function of q at all. So the new coordinate q, it is not a function of q at all. So we get 0. So therefore, we can say that p is a constant. So similarly, we have to find out q dot from the Hamilton's equation. So the Hamilton's equation says dk, the new Hamiltonian, by so we have the partial derivative of k with respect to the new momenta p. So what we get here is omega. Therefore, q is omega t. So from this we can say that q is directly proportional to t. So the graph that you would get would be a straight line, right? So it would be a straight line. So this is your right option. So just note that in this question, when we had found the new Hamiltonian k, now the generating function is not a function of t at all. So the generating function will just become the time derivative of the generating function will just become 0. So this would just be your old Hamiltonian, but you have to substitute for the old Hamiltonian in terms of the new variable. So this would just be p square by 2m plus half m omega square q square. But now we have to substitute p in terms of we found this value of p, small p, in terms of the new coordinates p and q. So substitute that in that place, and then we found the value of q also. We found out the value of q. Here we found out the value of q. So you have to substitute this also in that place. So this p and q, when you substitute in terms of the new coordinates, you will get your answer here, which is omega p.